Next topic is lipid metabolism. Because most lipids are nonpolar, that means they're hydrophobic molecules, they do not dissolve in water. Okay, most of our body is water, and blood plasma, where these lipids go, is actually over 90% water. The lipids do not dissolve in that water. So there needs to be something done in order for these lipids to travel inside of the bloodstream. These lipids must be transported combined with proteins produced by the liver and intestines. Okay, so the lipids in the blood are combined with the proteins that will need to be transported through the blood, and these are called lipoproteins. Okay, the proteins produced by the liver and intestines, these are special proteins that transport lipids in the blood. This is what they look like. Okay, this is a lipoprotein. Inside of it, there are lipids. There's two types of lipids: triglycerides, these orange, most of them, and maybe zoom out a little bit so you can see better. Okay, and also these yellow ones called cholesterol. Okay, and around them there's a shell of phospholipids, these blue guys, yellow cholesterol molecules, and these green ones, these are the proteins. So what makes the shell a lipoprotein is because it's combined and made from proteins and blue and yellow lipids. And inside of them there's triglycerides, fats, and cholesterol that needs to be transported somewhere. There are 4 classes of these lipoproteins. They can be called chylomicrons. Very low density lipoproteins known as VLDLs. Low density lipoproteins, LDLs. And high density lipoproteins, HDLs. Chylomicrons, they transport dietary lipids to adipose tissue. Okay, so if there's fats that we eat, chylomicrons will transport these fats from the gut to the bloodstream to the adipose tissue, to the fat tissue to be stored in our body. The VLDLs transport triglycerides from hepatocytes to adipocytes. Okay, so the triglycerides that reach hepatocytes, the liver cells, okay, they will be transported to the fat tissue, to the adipose tissue. Adipose tissue is made out of adipocytes, so the fat tissue in our body, by these VLDLs. The LDLs carry about 75% of the total cholesterol in blood and deliver it to the cells. Okay, so cholesterol is a molecule that has a bad rap, but this molecule is actually also useful in our body for various things. For example, it is a part of these lipoprotein membranes as well as all of the membranes in our body cells. Cholesterol is actually a useful molecule. We just can't have too much of it in our blood, because if we have too much of the cholesterol in our blood, that's going to create plaques, the blockages inside of the blood vessels. So 75% of the total cholesterol in blood delivered to the cells by the LDLs. Okay, and then HDLs, the high density lipoproteins, they remove excess cholesterol from the body cells and the blood and transport it to the liver for elimination. So LDLs, they carry cholesterol to the cells, and HDLs, if there's too much of that cholesterol delivered to the cells, they can remove extra that cholesterol from the body cells and the blood and transport it to the liver for elimination entirely from the body. So these are considered like the good cholesterol containing lipoproteins. So if you ever hear like HDLs are good cholesterol, that is because HDLs, they transport extra cholesterol inside of them outside of our body for elimination. So they transport it to the liver for elimination. Lipid metabolism, continuing. Cholesterol comes from some foods. There's lots of cholesterol containing egg, dairy products, that means milk, and milk products like regular milk, ice cream, cheese, even yogurts, organ meats, or like fatty meats, like any kind of type of meat from an animal source, of course. So most cholesterol is actually synthesized by hepatocytes. So cholesterol doesn't just come from foods, but it is also can be made by our own liver cells. Increases in total cholesterol levels are associated with a greater risk for coronary artery disease. Coronary artery is the artery on top of the heart, it delivers blood to the heart muscle. And cholesterol causes the blockages in the arteries in our body, especially dangerous if it's the artery on the heart, because it could cause a blockage of that heart artery and a heart attack. Exercise, diet, and certain drugs are used to reduce high cholesterol levels. So eating diet low in fat, avoiding eating too much eggs, avoiding eating too much dairy, avoiding eating too much meat. So kind of like eating some but not too much of it, not making your diet primarily made out of the animal source. So including lots of plant-based foods in your diet, like grains, potatoes, fruits, vegetables, that would help to balance the amount of cholesterol that's coming into the body. Also, it is known that oatmeal has the tendency to decrease the cholesterol in the body. So eating like a bowl of oatmeal in the morning could also help with the lowering of the cholesterol levels in our blood. What are lipids used for in a body? So just like glucose, lipids can be oxidized to produce ATP. If the body does not need lipids at any given time to produce ATP, they can be stored in fat tissue, just like glucose can. Lipids are not stored in the liver as the glycogen, as opposed to glucose, so lipids can be directly stored in the fat. Some lipids are used in structural molecules or to synthesize other essential substances. So glucose is not really used for that, but lipids are used for building certain things in our body that are either structural elements, for example, the membranes, plasma membranes of our cells. So the adipose tissue, that means the fat that's stored in our body, it could be like the fat under the skin or around the organs. This adipose tissue is made out of cells called adipocytes, and they can remove triglycerides from the chylomicrons and VLDLs. So the VLDLs, triglycerides, constitute about 98% of all body's energy reserves, because the fat that is stored in our body's adipose tissue can be converted to the energy, can be oxidized to produce ATP. Lipid catabolism is the process of splitting triglycerides into fatty acids and glycerol, the two components of the triglycerides. Lipid anabolism is the process of synthesizing lipids from glucose or amino acids. So we already saw that the glucose can be made from the lipids, but lipids can also be made from glucose. Okay, and so creating the lipids from glucose or amino acid is called lipogenesis, and splitting lipids for the production of the energy or to the production of triglycerides and fatty acids is called lipolysis. Okay, so to summarize the lipid metabolism, this is a diagram that summarizes the lipid metabolism. The green arrows indicate lipolysis and the orange arrows indicate lipogenesis. So lipogenesis is birth of lipids. Genesis, birth. Lipo is lipids. Okay, so here we have triglycerides. Okay, triglycerides are made from glycerol and fatty acids. So both glycerol, orange arrow, and fatty acids create triglycerides. Okay, where do fatty acids come from? Fatty acids come from the acetyl coenzyme A creation of the cellular respiration. So this is a process of cellular respiration that we saw earlier. That's when the glucose is converted into energy through a series of processes. Okay, in addition to creating energy, this process creates fatty acids. Okay, these fatty acids can be used to make triglycerides, can be used to make fat. Okay, this process also creates glycerol. This is a second constituent of the triglycerides to be used as fat. So remember, when the glucose is burned for energy, if some of it is not used, it can be converted into fat. So this is glucose being converted into the fat. Okay. So same thing, amino acids can be used to make triglycerides, but first amino acids have to enter the cellular respiration process, and then whatever is not used will be converted into the fatty acids that can be used for triglyceride formation. Opposite reaction. So triglycerides can be used to make energy by first breaking them down into glycerol and fatty acids, and then using these molecules for cellular respiration. That is the same process that breaks down glucose to make energy. The same process will also break down amino acids to make energy and triglycerides to make energy. Okay. As a result of this process, there is ketone bodies produced. Ketone bodies are the waste products of our body. Okay. And the ketone breakdown happens in most body cells. Ketone breakdown can be kind of like reused to make energy. But also, this process creates ketone bodies, and this is called ketogenesis, production of ketone bodies. That only happens in the liver cells. So basically, like if this process happens in liver cells, then their ketone bodies will be produced, and these ketone bodies can be reused by most body cells to make energy.